Hello everybody, it's me, Code Choker Looter, signing in for another episode of the channel, and here we are with a brand new course. We already have the Python course, we already have the JavaScript course, but I always wanted to show you also the C Sharp course, which is one that I am more familiar to, because I know a little bit about Unity and C Sharp. Therefore, the Learning C Sharp programming course, it is here. Granted, thanks to PackTV, I actually am subscribed to PactPub. Therefore, all books here are already full for the taking. Let me do something here. There we go. Perfect. So, as you guys can see here, we got this book, Learn C Sharp Programming, by Marius Bansila, Tripathi Rialdi, Ankit Sharma. I'm reading here over here, by the way. And this is the preface. I can't find this book around on the internet. Therefore, what I'm going to do is provide you the written texture here in this book. And then we are going to go reading along from chapter through chapter. So it's going to be a very lengthy but very complete understanding of the language of C Sharp. Without further ado, guys, let's get going to the table of content. That's the preface, by the way. So who this book is for? If you're a passionate programmer and want to learn C Sharp, this book is for you. If you want to start learning to program and want to do that with C Sharp and .NET, you will also find the book valuable. However, we assume you have some basic knowledge of programming concepts, such as what a compiler is, what classes and methods are, and so on. So basically, this book is for everybody. If you do not know C Sharp, this book is for you. If you do know C Sharp, this book is for you as well. What this book covers? So in chapter 1, we're going to starting with the building blocks of C Sharp. Chapter 2, data types and operators. Chapter 3, control statements and exceptions. Chapter 4, understanding the various user-defined types, provides information about classes. Chapter 5, object-oriented programming. Chapter 6, generics. Okay, it's full generic. Chapter 7, Collections, provides a walkthrough of the generic collection from the .NET Framework. Chapter 8, Advanced Topics, contains a variety of more advanced features such as delegates and events, tuples, extension methods, pattern matching, and regular expressions. Chapter 9, Resource Management, explains how the garbage collector works and how you should handle resources. Chapter 10, Lambdas, link queue, and functional programming. Chapter 12, Chapter 11, Reflections and dynamic programming. Chapter 12, Multi-threading and asynchronous programming. Chapter 13, Files, streams, and serialization. Chapter 14, Error handling. Okay, Chapter 15, New features of C Sharp 8. You must understand that this book is from 2019 or 2020, I believe. Also, Chapter 15, Chapter 16, C Sharp in action with .NET Core 3, and Chapter 17, Unit testing, covers unit testing. Okay, perfect. All right, to get most out of this book, you can read that for you. I don't wanna read that part. Download the example codes. It's here, but we're gonna write them on anyway, so we can learn together, of course. Code in action. Videos for this book can be viewed at... Okay, you can also see other videos about this code. Download the color images. Okay. Convention used here is the following. It's going to be very, like a generic. It's not going to be colored, I believe. So, but you can see with me that it's going to be colored anyway. When we wish to draw your attention to a particular part of the code block, the relevant lines or items are set in bold. Okay, so read only, and any command line input or output is written as follows. Okay. Get in touch. You can get in touch with everybody in PactPub with here. Okay, review next chapter. So the chapter 1, starting with the building blocks of C Sharp. C Sharp is one of the most widely used general-purpose programming languages. It is a multi-paradigm language that combines object-oriented, imperative, declarative, functional, generic, and dynamic programming. C Sharp is one of the programming languages designed for the Common Language Infrastructure (CLI) platform, which is an open specification developed by Microsoft and standardized by the International Organization for Standardization and European Computer Manufacturers Association (ECMA) or ECMA, that describes executable code and a runtime environment to be used on different computer platforms without being rewritten for specific architectures. Over the years, C Sharp has evolved with powerful features released versions by version. The most recent version at the time of writing is C Sharp 8, which has introduced several features to empower developers to be more productive. This includes nullable reference types, ranges and indices, asynchronous streams, default implementation of interface members, etc. etc. In this chapter, we will introduce you to the language, the .NET framework, and the basic concepts around them. Okay, so we're going to learn the history of C Sharp. Hey, that's not bad. Okay. C Sharp development started at Microsoft in the late 1990s by a team led by Anders Hellsberg. Initially, it was called Cool, but when the .NET project was first publicly announced in the summer of 2002, the language was renamed C Sharp. The use of the sharp suffix was intended to denote that the language is an increment of a C++, which along with the Java, Delphi, and Smalltalk acted as an inspiration for the CLI and the C Sharp language design. The first version of C Sharp, called 1, was made available in 2002, bundled with .NET Framework 1 and Visual Studio .NET in 2002. Since then, major and minor increments of the language have been released together with a new version of .NET Framework and Visual Studio. The following table lists all of the versions and some of the key features for each of these releases. Excuse me. As far as you can see here, thank you very much, that's better. The latest version of the language at the time of writing, 8, is being released with .NET Core 3, although most features will also work in projects targeting .NET Framework. Okay, understanding the CLI. The CLI is a specification that describes how a runtime environment can be used on different computer platforms without being rewritten for specific architectures. It is developed by Microsoft and standardized by ECMA and ISO. The following diagram shows the high-level functionality of the CLI. C# code, F# code, Visual Basic .NET code. All the compilers go to the Common Intermediate Language, Common Language Runtime, Common Language Infrastructure. Okay, common types of systems. The CTS is a component of a CLI that describes how type definition and values are represented, and memory is intended to facilitate the sharing of data between programming languages. The following are some of the characteristics and functions of the CTS. It enables cross-platform integration. It provides an object-oriented model that supports the complete implementation of many programming languages. It provides rules for languages that ensure that objects and data types of objects written in different programming languages can interact with each other. The CTS supports 2 categories of types. Value types. This contains their data directly and have copy semantics, which means when an object of such a type is copied, its data is copied. Reference types. These contain reference to the memory address where the data is stored. When an object of a reference type is copied, the reference is copied and not the data it points to. Common Language Specification. The CLS comprise a set of rules that any language that targets the CLI needs to adhere to be able to interoperate with other CLS compliant languages. CLS rules fall into the broader rules of the CTS, and therefore it can be said that the CLS is a subset of CTS. All of the rules of CTS apply to the CLS unless the CLS rules are stricter. Okay, you can see here CTS, Visual Basic, F#, C#, C++, CLI. The CLI is intertwined. Okay, Common Intermediate Language. CIL is a platform neutral intermediate language, formerly called Microsoft Intermediate Language, or MSIL, that represents the intermediate language binary instructions set defined by the CLI. It is a stack-based object-oriented assembly language that represents the code in bytecode format. Once the source code of an application is compiled, the compiler translates it into the CIL bytecode and produces a CLI assembly. When the CLI assembly is executed, the bytecode is passed through the just-in-time compiler to generate native code, which is then executed by the computer's processor. The CPU and the platform-independent nature of the CIL makes it possible that the code is executed on any environment supporting the CLI. To help us to understand the CIL, let's look at an example. The following listing shows a very simple C# program that prints a hello world message to the console. Okay, time to code. Wait for me a little bit. Okay, not so much time to code, but I have the code anyway. So it explains something here. It is possible to view the content of the assembly produced by the compiler using various utility tools, such as the ILDASM.x, which comes with .NET Framework, or ILSpy, which is an open source .NET assembly browser and decompiler. Here's the link for the ILSpy.net. The ILDASM.exe file shows a visual representation of the program and its components, such as classes and members. As you can see here, you can also see that content of the manifest, which includes assembly metadata as well as the CIL code for each method. If you double click on it, the following screenshot shows the disassembled code of the main method. Method private hide by signature static void main string. As well, you can see there. Figure 13. Screenshot of the ILDASM tool showing the IL code of the main method. A human-readable dump of the CIL code is also available. This starts with the manifest and continues with the class members. Okay. I'm not gonna copy this. Of course not. We shouldn't copy this. Don't worry, guys. We shouldn't copy this. An explanation of the code here is beyond the scope of this chapter, but you can probably identify at a glance parts of it, such as classes, methods, and instructions executed in each method. Virtual Execution System. VES is a part of the CLI that represents a runtime system that provides the environment for executing the managed code. It has several built-in services to support execution of code and handling of exceptions, among other things. The common language runtime is .NET Framework's implementation of the virtual execution system. Other implementations of the CLI provides their own VES implementations. The .NET family of framework. Here we can see .NET Framework, .NET Core, and then .NET Xamarin. So framework, .NET Apps on Windows, distributed with Windows. .NET Core is a cross-platform apps distributed with app, and the Xamarin is a cross-platform apps that runs on iOS, macOS, Android, and Windows. All of these implementations are based on a common infrastructure that includes languages, compilers, and runtime components, and supports a variety of application models, and some of which are shown in the following screenshots. WPF, WinForms, ASP.NET, WCF, ASP.NET Core. Okay. The .NET Framework. I think this is very important to read actually. The .NET Framework was the first implementation of the CLI. It is the primary development platform for Windows Server and client developers. It contains a large class library that supports many types of applications. The framework is distributed as a part of the operating system, and as a result, new versions are serviced through Windows Update. Although standalone installers are also available, initially .NET Framework was proprietary software developed by Microsoft. In recent years, parts of the .NET Framework have been open sourced. The following table shows the history of .NET Framework as well as the major features as available in each release. I'm gonna give you this little quick view, and let's keep reading. In the future, Microsoft intends to unify all .NET Framework into a single one. At the time of writing this book, this is planned to be named .NET 5, which is the one that we have in my Visual Studio 2019, but it's not supported anymore. I need to upgrade my Visual Studio, that's for sure. .NET Framework includes the Common Language Runtime, which is the execution engine of the framework that provides services such as a memory management, type safety, garbage collection, exception handling, threat management, and others. It also includes an implementation of the CLI Foundational Standards libraries. The following is a list of the components of the standard libraries: Base Class Library, Runtime Infrastructure Library, Reflection Library, Network Library, Extended Numeric Library, and Parallel Library. Apart from these libraries, the .NET Framework class library includes many other libraries such as the WPF, WinForms, WCF, LINQ, and others. Most of these are in the system or Microsoft namespaces. A key aspect of developing in C# for the .NET platform is how memory is managed. In general, developers do not have to worry about the lifetime of objects and the disposal of memory. Memory management is automatically done by the CLR through the garbage collector. The GC handles the allocation of objects in the heap and the disposal of memory when heap objects are no longer used. The garbage collection is a non-deterministic process because it happens on a per-need basis and not at some indeterministic moments. Okay, .NET Core is a new implementation of the CLI that is cross-platform, open source, and modular. It is intended for developing a variety of applications, such as web apps, microservices libraries, or console apps that run on Windows, Linux, and macOS. The .NET Core framework is packaged using NuGet. As a result, it is either compiled directly into an application or put into a folder inside the application. Therefore, .NET Core applications distribute the framework components directly, although a cache system for a centralized deployment called Runtime Package Store is also available starting with version 2.0. Okay. Xamarin is a CLI implementation based on Mono, which is a cross-platform open-source .NET framework. In general, Mono API is followed with the progress of .NET framework and not .NET Core. The framework is intended for writing mobile applications that can run on iOS, Android, macOS, and Windows devices. Applications developed with Xamarin are native, which provide similar performances to those developed with Objective-C or Swift for iOS and Java or Kotlin for Android. Xamarin also provides facilities to directly invoke Objective-C, Java, C, and C++ libraries. Xamarin applications are written in C# and use the .NET-based class library. They can share most of the code, with only a small portion needed to be platform specific. Detailed information about Xamarin is beyond the scope of this book. If you want to learn more about this implementation, you should use additional resources. Assemblies in .NET. An assembly is a basic unit for deployment, versioning, and security. Assemblies can come in two forms, either as an executable file or a dynamic link library. An assembly is a collection of types, resources, and meta information that forms a logical unit of functionality. Assemblies are loaded into memory only if needed. For .NET Framework applications, assemblies could either be located in the application private folder or shared in the global assembly cache, provided they are strongly named. For .NET Core applications, this latter solution is not available. Each assembly contains a manifest that contains the following information: the identity of the assembly, a file table describing the file that make up the assembly, a list of assembly references that contains the external dependencies that the application needs. Okay. Global assembly cache. I don't think we did. I'm just gonna let this through for like a 2-3 seconds so you can read it out, but I'm not gonna read it. I really want to code right now. Runtime package. Let's see the table of contents. Okay, we are almost there. Ah! Okay, there we go. Global assembly cache. There we go. Runtime package store. Let me get the font size as largest possible. That's better, right, guys? That's better. Package store. So, understanding the basic structure of a C# program. Forgot about this as well. Okay, the content of this book, the source code accompanying this book was written in Visual Studio 2019. Awesome, so we're using the same version of the Visual Studio. And call the project Chapter 01. Okay. Okay. So this is basically how it's written. It's basically very simple, as you can see here. Let me change it for you right here. It's the same thing. It's the same thing over here. System namespace chapter 01. This is what I actually made. Visual Studio is just the same thing. Let's get going again. So the first line of the program using system declares the namespace that we want to use in the program. A namespace contains types, and the one used here is the core namespace of the base class library. On the following line, we define our own namespace called Chapter 01, which contains our code. A namespace is introduced with the namespace keyword. In this namespace, we define a single class called program. A class is introduced with the class keyword. Furthermore, this class contains a single method called main with a single argument that is an array of strings called args. The code within a namespace, types, and method is always provided within curly braces. This method is the entry point of the program, which means it's where the execution of a program starts. A C# program must have one and only one main method. The main method contains a single line of code. It uses the system console writeLine static method to print a text to the console. Static method is a method that belongs to a type and not an instance of the type, which means you do not call it through an object. The main method is itself a static method, but furthermore, it is a specific method. Every C# must have a single static method called main, which is considered the entry point of the program, and the first to be called when the execution of the program begins. Throughout the next chapters, we will learn about namespaces, types, methods, and other key features of C#. Summary: in this chapter, we'll look in short this history of C#. We then explore the basic concepts behind the CLI. So test what you learn. Ooh, exercises. Cool. So we have exercises here. When was C# first released, and what is the current version of the language? What is the common language infrastructure? What is the common intermediate language? Okay, I'm gonna put this right here. See, next chapter. I think it will be cool to do chapter through chapter every video. I think it will be like more understanding. I don't want to make, like a very lengthy video, like an hour video, like the other Python and JavaScript videos that I'm going to do furthermore. So I think chapter through chapter it's going to be nice. So let me see the table of content here though. Okay, that's fine. I'm checking all the check marks because I might get credits if I read a complete book. I believe that's how PactPath works. So that is the first chapter of this book. Thank you very much, guys, for being here, and see you guys next time for the chapter 2. Okay, so please click like, subscribe, and see you guys next time. Bye bye.